Section 6.5, Applications of the definite integral. So the average value of a continuous function f of x over the interval from a to b is defined as the quantity 1 divided by b minus a times the integral from a to b of f of x dx. And so if I want to find the average value that a continuous function takes on, this is the way that I can calculate that. So let's say that we want to find the average value of the function f of x is equal to 1 minus x from x is equal to negative 1 to x is equal to 1. Well, it's just a calculation. 1 over b minus a. b is going to be the further right one. a is going to be the further left one. And so this is going to be 1 minus 1 times the integral from negative 1 to 1 of the function 1 minus x dx. At this point, we just need to find the antiderivative, and I could also find this fraction on the far left. Well, the fraction on the far left is 1 divided by 1 plus 1, which is 1 half. And so that's 1 half times the integral. So I'm going to leave that 1 half outside of brackets. What is the antiderivative of 1? The antiderivative of 1 is x. And then the antiderivative of negative x is going to be negative x squared over 2. And then I'm going to take that from negative 1 to 1. And so that's my definite integral. For the sake of clarity, I'm not going to distribute this 1 half. I'm just going to leave it outside while we calculate the definite integral. And then once we finish with the definite integral, we'll distribute that 1 half over the number. But it'll just be a multiplication. And so that's going to be 1 minus 1 squared over 2, all minus negative 1 minus 1 quantity squared over 2. Well, then I get that this is 1 half times 1 minus a half plus 1 plus 1 half. And so I get 1 plus 1 is 1 minus a half plus a half is 0. And so I get that this is 1 half times 1 plus 1 is 2 times 2, or 1 half of 2 is 1. And so I claim that the average value that this function takes on between x equals negative 1 and 1 is specifically the value of 1. So let's assume that a country's population is now 3 million and is growing exponentially with a growth constant of 0.02. What will be the average population during the next 50 years? Now, it's useful to recall that our exponential growth function was p naught times e to the kt. And if we can recall that that was our population growth function, that's what we need first so that we can get the correct function. And so population growth function, initial population times e raised to the k, where k is the growth constant, times the time t. Now we'll just convert this to x's, but we're perfectly fine. So if I want to know what is the average going to be over the next 50 years, well, let's just go ahead and write this. We recognize that our growth formula is going to be 3 times e to the 0.02 times t, or x. I'm just going to go ahead and throw it in as x. Doesn't really matter. But then, that's our function that we need. Well then, if I want to find the average for the next 50 years, well, right now, what year is it? Well, that would be the 0th year. And so it's going to be 50 minus 0. And then our limits of integration are going to be from 0 to 50 of that function we just came up with, 3 times e to the 0.02 x dx. So this is the integral that we need to find the average value. So let's calculate our antiderivative. Of course, this is 1/50th times the antiderivative, which is going to give us 3 times e to the 0.02 x divided by the growth constant, 0.02, from 0 to 50. Now I'm going to clean this up a little bit before I try to evaluate the definite integral. And so because of these constants, I'm just going to pull them out. And that's really the same thing as 3 times 1 is 3, divided by 50 times 0.02, all times, and then we're just taking our definite integral e to the 0.02 x from 0 to 50. But then 50 times 0.02, that just gives me 1, and so I get 3 times e to the 0.02, e to the 0.02x from 0 to 50, just cleaning it up a little bit before I do the calculation. Then what do we get? This is then 3 times e to the 0.02 times 50 minus 3 times e to the 0.02 times 0, which means what are we going to get? Well, that's going to be, well, 0.02 times 50 is 1, so this is 3e minus 3e to the 0 power is 1, so it's 3e minus 3. And so 3e minus 3, that's approximately 5.1548, and of course our units are million. And so 5.1548 million people on average over the next 50 years if this growth curve is what we're following. Next, the consumer's surplus for a commodity having a demand curve P equal to f of x is specifically going to be the integral from 0 to capital A of f of x minus capital B dx, where specifically the quantity demanded is A and the price B is equal to f of capital A. So then let's do an example. Our example is find the consumer's surplus for the following demand curve at the given sales level X. So that demand curve, P, is equal to x squared over 200 minus x plus 50. And our sales level is going to be at x is equal to 20. Alright, so our quantity demanded, 20, is our A. And our function, f of x, is our demand curve, P, where of course that's our price curve, right? Then, if I want to find this B that's labeled, B is specifically f of capital A. And so that means that B is going to be 20 squared over 200 minus 20 plus 50, which I get then that B is equal to 32. Well then, all we need to do is take the integral from 0 to A, where A is 20, of our price curve, f of x minus the value B. And so our demand curve, price curve, is x squared over 200 minus x plus 50, and then minus the value B, which we have found to be 32, dx. And so this will give us the consumer's surplus. So the antiderivative of x squared over 200. Actually, let's clean this up a little. This is then the integral from 0 to 20 of x squared over 200 minus x plus 18 dx. And so our antiderivative, that's going to be x cubed over 3 times 200 minus x squared over 2 plus 18x over 1, and from our limits of integration, 0 to 20, then I get that this is 20 cubed over 600 minus 20 squared over 2 plus 18 times 20 minus 0 cubed over 600 is 0, minus 0 squared over 2 is 0, plus 18 times 0 is 0, which I then get to be approximately $173.33. And I did round because it was 0.33 infinitely repeating. So recall that when we're dealing with the antiderivatives or the derivatives of e to some power, then chain rule comes into play. And so previously, when we were taking the integral of e to the k times x dx, recall that that antiderivative was e to the kx divided by k. And so that was essentially our chain rule, of course, plus a constant c. And so that was our chain rule applied in reverse that allowed us to get the correct antiderivative. Well, recognize here that if I have e to the 2x plus 3, it's a little more complicated. And so this generic chain rule formula for e to the k times x, the antiderivative of that, isn't going to quite work the way we want. And so since that's the case, I claim that if we have a simple linear power, that is, one variable and a variable of 1 degree with a coefficient plus some constant, we can play a useful little trick. And the useful little trick is with the power rules, this is the same thing as e to the 2x times e to the 3 dx. But at that point, what matters is recall that e to the third is a constant. And so this is then e to the third times the integral of e to the 2x dx. So then we can use our general chain rule formula for the antiderivative of e to the 2x. This is then going to give me e cubed times e to the 2x over 2 plus some constant c. Well, of course, then we're really just worried about our definite integral situations, but regardless, notice that this then becomes e cubed times e to the 2x, but then you can regroup that together, and that's e to the 2x plus 3 all over 2. Of course, with an indefinite integral, it needs to be plus c. And so what that tells us is that if I'm trying to find the antiderivative of e raised to some ax plus b dx, where a and b are just some constants, then this actually simplifies to become e to the ax plus b divided by the coefficient of x, a. Now, of course, with an indefinite integral, it's true that you've got to have the c, but remember that when we're dealing with a definite integral, you can just drop that c value. Well, now the reason that we want to talk about that is because the future value of a continuous income stream of k dollars per year for capital N years at an interest rate lowercase r compounded continuously is specifically going to be the integral from 0 to capital N of k times e to the r times capital N minus t dt. So then let's suppose that money is deposited daily in a savings account at an annual rate of $2,000. If the account pays 6% interest compounded continuously, approximately how much will be in the account at the end of 2 years? Alright, so what's our integral? Well, this is then going to be an integral from 0 to how much time do we have? 2 years of the k, which is 2,000, that's the amount put in. So here is our k, here is our r, here's our capital N, 2 years. Okay, so 2,000 e to the r. Remember that 6% is 6 divided by 100, or 0.06, and so that's 0.06 times n minus t, which is 2 minus t dt. Well then, if you want to clean this up, we can go ahead and distribute that 0.06, and so this is going to be the integral from 0 to 2 of 2,000 e raised to the 0.12 minus 0.066t dt. Well then, using the formula we just came up with previously, right there, this is then going to be, when we find the antiderivative, this is going to be 2,000 times e raised to the 0.12 minus 0.06t divided by the coefficient of t, which is negative 0.06. And then from our limits of integration from 0 to 2. And so then, what's this going to be? This is going to be 2,000 divided by 0.06 is actually going to be 3.33 repeating infinitely. And it is negative. And then we can just do our limits of integration plugged in. That's going to be e to the 0.12 minus 0.06, where t is 2, minus e to the 0.12 minus 0.06 times 0. And I get that this is then going to be negative 33,333.33 times negative 0.127. And this is technically an approximation once I get here. But then rounding this to the closest penny, I get that this is approximately $4,249, and I had 895, which rounded to the nearest penny is $0.90. Should be in the account at the end of 2 years. And lastly, the volume of the solid of revolution obtained from revolving the region below the graph up from A to B about the x-axis is going to be given by the integral from A to B of pi times our function g of x quantity squared dx. And so to give you an image of what's actually happening here, suppose that we have an xy coordinate plane. And then let's suppose that we have some function, g of x. And I'm just going to do something kind of basic so we can hopefully see the shape. If this is our function, and let's say that this is A, and this is B. Well, when we say this thing is spun around the x-axis, well, what actually happens? Well, if you were to spin this, then you would get a mirror image down below. And you have to pretend that I'm actually getting the correct mirror image. And then the solid of revolution that we actually get looks like what? Well, if you rotate it, you're then going to have this figure. And so hopefully you can see this three-dimensional shape, but what you're actually finding is you're finding the volume of the three-dimensional figure that I just sketched. And so that's really what we're doing here. So then, and this works for any function g of x as long as g of x is above the x-axis, all that good stuff. Now, of course, this will simplify as pi times the integral from a to b of the function g of x quantity squared dx. And so you can simplify it in that fashion. And so then we get that to find our solid volume, that's going to be pi times the integral from 0 to 2 of our function 2x minus x squared quantity squared dx. Well, the first thing we have is a binomial multiplication, so I do need to take care of that. That's going to be pi times the integral from 0 to 2 of, first, that's going to be 2x times 2x is 4x squared. Outer is minus 2x cubed. Inner is minus 2x cubed. Last is plus x to the fourth dx. And one last that we can clean it up. This is then going to be pi times the integral from 0 to 2 of 4x squared minus 4x cubed plus x to the fourth dx, which then is pi times, find our antiderivative, that's going to be 4x cubed over 3 minus 4x to the 4th over 4 plus x to the 5th over 5 from 0 to 2. So I get this is then pi times 4 times 2 cubed over 3 minus 4 divided by 4 is 1, and so that's going to be 2 to the 4th plus 2 to the 5th divided by 5 minus, but recognize that when we plug in 0, 0 cubed is 0 minus 0 plus 0, and so subtract 0, just that whole subtraction there, which I get is then going to be 16/15 times pi. If they want the exact value, that is the exact value. If they want an approximation, you can, of course, find that this is approximately 3.35 cubic units, because if we're talking about volume, then it's cubic units.